welcome. Take a look at this slide as an introduction. Imagine you're in a parking garage. The parking garage charges by the hour. So if you stay up to 1 hour, you have to pay $2. If you stay up to 2 hours, you have to pay $2.75. If you stay up to 3 hours, you have to pay $3.50, and you have to pay $5 if you stay anytime over 4 hours. Which graph displays the information correctly? Take a look. All right, the answer is that this graph right here displays it incorrectly. So let's say you stay for an hour and a half. We go an hour and a half on the x-axis, then you have to pay $2.75. If you stay 6 hours, 1, 2, 3, 4, 5, 6, then you have to pay $5. Is that correct? 1, 2, 3, 4, 5. Yeah, $5. We're good. Okay. What's wrong with this one? Why is this graph not fair? It's because look at all these points right here on this vertical bit. Can you see that what that's really saying is if you stay 1 hour, you might have to pay $2. You might have to pay $2.10. You might have to pay $2.15. You might have to pay $2.50. It's not really clear exactly how much you have to pay if you stay exactly 1 hour. Not a good graph. How about here? What's wrong with this one? Well, obviously, if you stay an hour and a half, looks like you don't have to pay anything. So that can't be correct. All right? Just want to let you know, this represents a function, this graph right here. Functions are always fair. Okay? Objective for today is to determine whether a relation is a function. Take a look at this. Here you have a drink vending machine. It also says a function is a relation where each x is paired with only one y. These are some really simple questions. Is the machine functioning if you push the red button and you get a red Gatorade? Yes, of course. Is the machine functioning if you push the red button and you get a purple Gatorade? No. It doesn't make sense that you're expecting to get purple and you get red. You get something different than what you expected. Is the machine functioning if there are two different buttons for a red Gatorade, like this and this? You could push this, or you could push this and get a red Gatorade. Yes, it is functioning. That happens all the time. Okay. Remember, a function is a relation where each x is paired with only one y. Okay, take a look at this graph. Function or not a function? Not a function, why? Well, if I go to this x, if I go to 1, then sometimes y is 2 3/4 or so, and sometimes it's negative 2 3/4. There's two y's associated with that one x. Try this one. Why is this a function? For each x, there's only one y. Yeah? For each x, there's only one y. Let's look at this one. Function or not a function? Not a function. This one, if we go to 1, there's my x. There are two different y's. How about this one? Function or not a function? Not a function. Because if you go over to 1, 2, 3, if you go over to 4, there's my x. There are 3 different y's. If I put in 4 to the function machine, I could get 0, -1, or -2. You can tell something is you can tell graphs are a function or not a function by using the vertical line test. What you do is you're going to hold up your pencil, and that will be your vertical line. Let me make a vertical line. Oh, here we already have one. Here's a vertical line. I'm going to run my vertical line right over the graph. You see how there's only one y for every x? It never hits 2 points at the same time. Let's try down here. It only hits 1 point at a time. How about if I go right here? It's only hitting 1 point because there's a hole at the top. Whoops. There we go. Here are the ones that are not functions. Oh, it's hitting 2 points. at the same time. If it's hitting 2 points, then it's not a function. Okay? That's kind of like saying if you want to buy a pizza, sometimes the cost is $1 and sometimes the cost is negative $1. Okay? Let's do this way. When I get right here, oh, it's touching 2 points at the same time. Not a function. Okay? Think of it this way. Let's say you go to the movies and you're going to buy some candy. Does this make sense? Would this machine function correctly? The answer is yes. You could have 2 different candies that both cost $1. That would be fine. How about this? Would this be functioning correctly? The answer is no. You can't have Bubble Yum charging $1 for some people and 75 cents for other people. Not a function. That would be a machine that doesn't function correctly. All right. For the next 4 slides, we just have to figure out, is it a function or not a function? Yes or no? This one, not a function. I'll write it in. Why is it not a function? It's not a function because for this x, there are 2 different y's. Function or not a function? Yes, this one is a function. Why? Because for every single x, there's only one y. Okay? It doesn't matter if there's 2 x's that have the same y. Okay, function or not a function? We're doing it as tables now. Well, look here. Function. For every single x, there's only one y. How about here? So this one, yes, function. Take a look at the next one. Function or not a function? Well, take a look at this x and this x. Are those the same x's? Those are the same x's, but they give us different y's. Not a function. Not a function. Oh, here we've got ordered pairs. Function or not a function? I find ordered pairs really hard to see. So you might want to go ahead and make a little mapping. 1 goes with 4. 2 goes with -2. That's fine. 3 goes with -6. That's fine. -6 goes with 3. That's fine. -3 goes with oh, whoops. We already have a -6, don't we? -3 goes with -6. Okay, function or not a function? This one, yes, this one is a function. You might have just been able to tell that by looking. All the x's were unique. Right? How about down here? Function or not a function? Well, I bet you can tell right away that 2 of these x's are exactly the same. And when we look carefully, they give us different y's. So is that going to be a function or not a function? Not a function. Okay. What you can tell here, if you wanted to map it, was you could say 6, -4, 2, -4, -4, 2, 4, 6, 2, whoops, we already have a 2, 6. This is the problem right here. Okay, moving on. Compare and contrast these following mappings. It's really hard to tell something is a function or not without graphing it. So we need to sketch a graph. You already know that this is the y-intercept, so 3 is about here. You know the slope is going to be up. You know it's going to be a straight line, right? Function or not a function? Function. Use the vertical line test, right? If you drew some vertical lines, they would only cross the graph once. Let's graph this one. What's the line where all the x's are 4? Where x is always 4? Is that going to be vertical or horizontal line? It's going to be a vertical line like this. So obviously a vertical line cannot be a function. Does not pass the vertical line test. Not a function. All right, pause for. Okay, the second part of this lesson is using this new notation, f of x. Okay, it's called function notation, and we call it f of x. Basically, it replaces the y value. So this means the same thing as y equals 4x minus 3. We just say f of x equals 4 minus 3. So take a look at some examples. If this is f of x, then f of 5 equals 3 times 5 minus 2, which is the same thing as 15 minus 2, which is 13. Good? Let's try a different equation. Let's try h of negative 2. H of x is a different function. That's why it has a different letter. So h of negative 2 would equal 3 times negative 2 squared minus 2 times negative 2. All right, how do we do this? Negative 2 squared is 4 times 3 minus negative 2 times negative 2, that's going to be plus 4, so that's 12 plus 4, which is 16. Let's make them a little harder. What if you have f of 12 plus 7? Try this. Well, f of 12 plus 7 is equal to 3 times 12 minus 2 plus 7. Okay? So 36 plus 5, combining these two terms, equals 41. Let's try one more. A little harder. Let's try h of negative 1 plus 5. Let's try h of negative 1 plus 5 is going to be equal to 3 times negative 1 squared minus 2 times negative 1 plus 5. Okay? So negative 1 squared, that's negative 1 times negative 1 is 1, times 3 is 3. Negative 2 times negative 1 is plus 2, plus 5. Altogether, we've got 10. All right, try this one, getting a little harder. F of A. Well, all you're doing is you're replacing the variable with A. So this is actually really easy. F of A equals 3A minus 2. Let's make it a little harder. Try this one. F of A plus 7. Okay, F of A plus 7 is going to be 3 times A plus 7 minus 2. Well, how do we simplify this? You're going to have to distribute that 3. So this is equal to 3A plus 21 minus 2, which is equal to 3A plus 19. Done. Should we try a little bit harder? Last one. Okay, this time we're doing H of 3C. So we say that H of 3C, we're going to have to use this function up here, is equal to 3 times, now we have to replace x with 3c squared minus 2 times 3c. Make sure you understand that. All right, here's the tricky part. When, remember exponent rules, we're going to have to distribute that. We're going to have to square the 3 and the c. So I'm going to do this a little slowly. We've got 3 times what